excited to be here in London. Today I'll be diving into three topics to make it role of large language models in development workflows. So AI-assisted development is on the rise. We are seeing engineers using it for writing code in various languages, such as PyCon, JavaScript, Java. People are generating tests using LLMs in various frameworks, which include unit tests and integration tests. And then we have engineers using it for documentation, for writing development experience, writing AI descriptions, and writing documents. So actually, the usage of AI tools is on the rise. 70% of professional developers were using or planning to use AI in the development process, according to the Stack Overflow 2023 developer survey. Here's a review by Arbisoft, who served as the director of AI at Tesla. He says that co-piloting has dramatically accelerated his coding. It is hard to imagine going back to manual code. It already writes 80% of my code with 80% anyways. I don't need really code, I return the error. So this is back in 2022 when Copilot was just launched. And now the accuracy is much better. So the natural question is, why are these AI tools growing in popularity now? There are two reasons for this. The first one is that there are strong repeated elements like GPT-4, Claude, and Jellybank, which are generating code with better accuracy and fewer errors. Here is the performance of some open source LLMs and closed source LLMs on the human development dataset consisting of 164 programming languages to run Japanese in Python. And you can see that over the span of just 2 years, the performance has gone up from 48.1% to 84.9%. And it is continuing to increase. The Cloud 3 model is a model that was launched by Azeemi just a few weeks ago. And the second one is that AI co-pilots are integrating LLMs directly within the coding workflows. For example, YouTube Copilot is very good at generating code with machines. The cursor code editor handles questions about the code base really well. And the coding generates unit integration tests with further packages. So how do these co-pilots work? There are two primary mechanisms that are running behind the scenes. The first one is prompt engineering. So GitHub Copilot relies on a ton of prompt engineering on top of those pre-trained LLMs that I mentioned before to provide you contextually relevant suggestions. And the second one is retrieval augmented generation, which involves combining an external knowledge source with an LLM for answering questions about the code base. Here is a code validation pipeline that GitHub Copilot uses behind the scenes. So it's a fairly complex pipeline. It starts off by getting data from the open tabs, from the editor, and then waiting for the vector database, which contains the contextual abilities about the code base. All of this data is passed into a prompt library, from where we select the relevant prompt. That prompt is then filled in with all the data from these three different sources. And it is then passed into the contextual filter model, which basically decides whether that request should be passed on to GPT-4 or not. If the user is not accepting certain suggestions, then it just rejects that request and doesn't pass it to the editor. And then we have a natural GPT-4 model that generates the particular code completion. And in fact, multiple completions are generated, of which top key are selecting and returning users.
Boy, this thing.
Here's a code generation pipeline which works when you are asking questions about the code base. So what happens is that we have source code. It is first split out into individual chunks and it ends into a vector store in the form of embeddings. So you can think of embeddings as real value vectors that encode the specific meaning of particular code pieces. And it relies on context-aware state, which means that the data from certain functions is grouped together and then passed on to the embeddings in rest mode. Once the data is indexed into a vector store, it is ready to be used by the LLM for answering questions about the code base. So whenever a new question comes in, a user asks a single question about the code base, it performs semantic retrieval over that vector store. It gets all the relevant chunks and then it passes them as the context to that particular area, which then generates the particular answer. So this pipeline is used by the Copilot chat, which allows asking questions about the code base. Now, while these AI tools are gaining so much popularity, there are still certain challenges that are associated with using these in your daily development workflow. The biggest challenge that people are seeing right now is inadequacies and vulnerabilities in the generated code. According to the Stack Overflow Developer Survey, conducted in 2023, only 2.85% of developers highly trust the output of LLMs, and the rest of the developers are somewhere in the middle. They somewhat trust or somewhat distrust the output of these LLM tools. But this situation is changing rapidly as we are getting stronger pre-trained LLMs that are reducing the hallucinations and generating code with better accuracy. And the second primary challenge when working with these LLMs is their data privacy and security. So some organizations are not comfortable with using closed source LLMs like GPT-4 for entering up on their code base. So what they are doing instead is that they are either training their own LLMs and deploying them in-house, or they are using some strong open source LLMs like Llama, Mistral, or Code Wizard, and then deploying them on the private network or on web. Now I would like to call in Yahya, who will talk about his experience for the past 5 years and then reimagining it by using analytics. And
hello everyone, I think I'm audible. So let's get into it. What I'm going to do here is try to travel 5 years back and start from very basic. My first day as a software engineer and travel till today, and looked at very extreme examples throughout this journey and how and if LLM is doing any good given it was 5 years ago. So this is the agenda. I'll compare and contrast, and then I'll rate those outcomes based on how good an LLM is doing. Keep things very simple. We're going to rate them on a scale of 3. If you see a single Python and you're a slide that means it's doing really bad, and I rather do it myself, if you see 3 Pythons on a screen, it's doing a good job and I can improve on that. And if it's giving out like 5 Pythons on the slide, that means my job is done. This job can be automated right from the go. Let's start. It's year 1. I am learning and writing code. So I'm learning as a training. I'm training as a fresh graduate. So training as a fresh graduate right out of the university, I'm diving deep into documentation and reading out what's their understanding of any framework. And then to practice my understanding, I just get into some intro to Django or something similar, guys. There is a very basic project out there that is starting to do. How does this workflow change with the LLM? Because so the learning of the concepts is a little different now. I don't have to jump deep into documentation Rather, I have an assistant right up my sleeve where I ask questions such as what are negative methods in Python, and it will spit out the most accurate description from that. Moving forward, the second most important part is practicing. And it's really hard to get a really good practice problem because all the framework, what they really want you is to land on the page and get started with the framework. Rather than giving you some real technical understanding of how this is going to pan out in a real world. So LLM really helps me in that regard as well as a fresh grad again, where I can ask it to just pick out a practice problem, let's just say here, based on list comprehension. And it will come up with an interesting problem that I can solve to enhance my skill. Second part is driving to the actual goal. So when I'm learning, and all of us, I believe in this room, have been learning through YouTube, tutorials, Stack Overflow, or even Geeks for Geeks. All this combined and separated knowledge, when it transforms into a code, it doesn't really look good because that code is built to get things done rather than being production ready. So to add on that layer of security, where my code that I've written based on all my learnings from YouTube, Stack Overflow, all these sources, I need a peer review session, especially from my mentor that reviews my code and helps me identify these are the areas that you need. Well, let's have a look at this code. And I believe all of us in this room should have done this. That you need to read command line arguments into Python and work something based on that. And looking at this code, if I am starting now doing developing Python, it seems really good to me. What anyone who's been developing in Python for some time knows that this code is quite smelly and ugly, Python nowhere to go. It's not good to go into production. So what LLM can help me here is, without the help of mentor, give me an output that, hey, look, what you may do is use an argument parser library that will help you validate this as well, get this code to run something. So I don't really need to go to a mentor to get this wisdom that, hey, your code looks ugly because you have learned from different sources. It's right here for me to start with. All right. Things are about very serious, but not that much. I'm in year 1 and year 2. What I'm looking at is I'm starting to train others like I got trained, right? And to train someone, I really believe that you need to bring in real life stories or some inspirational stories where you find and mix your problems with these use cases, come up with a problem statement that someone should be solving to engage their us. So what I used to do when I was training is go to Reddit and go to technical documentation. I'll pick out topics from technical documentation. I'll pick out prompts from Reddit, combine these two up, and voila, you have an interesting story that a fresh graduate will be solving as well as assignment. And for the way forward, let's say the fresh graduate and training is working on Python Gen, but I'm working on fast GPI. So to review this code, I need to revise my Python Gen, go back into the documentation again, and then provide some useful feedback. Well, these steps are kind of skipped with LLMs again, because they are really good with combining something, let's just say an app from LLM, and combining it with the problem of, you can say, counting all the numbers in Python. And you can see here that it says that you need to count the entries in the store. And the second part is the code review. It's very interesting that it can highlight the very basic problems because Python code has been around for very long. And you can see even without reading the code, at the part I'm highlighting, you can identify that, hey, this code needs some better exception handling because LLM just points it out. So I don't really need to go back and learn something and revise it from Django, rather than LLM will do that right for me. And now coming to the technical part of my issue is that you have to face a legacy code base and you need to learn about more legacy code base to do a new contribution into the field. And you're also afraid that they might change would eventually break something in production. And maybe this is going to be the worst of life. Let's have a look at this very function. This minutes was something that I saw in real life, where a function was needed, it should never be changed. And if we're changing this, your company valuation is going to go down. And there are a lot of weird things happening in this function function. So I can be spending days and days reading a code like this, still trying to figure out what and where it's trying to do, but never able to catch up all the SDSs this code potentially have for impact on the code which I'm writing. So how does LLM help us here? Is that not only I can ask it to explain what this code is doing, it can also help me identify some of those triggered edge cases. For example, a note down here says you want to be very careful because there's a loop, but they're starting from index 1 and they are skipping out the 0th index. So I want to consider that why they're skipping this 0th index right from the way. And it just doesn't stop here. I can ask this LLM to just write me unit test cases so that I can better understand what this code is doing. And that's the just next step, where it just generates me a couple of unit test cases, figuring out and highlighting for me the edge cases that I need to worry about while changing this. And that is straightforward. And once I'm done with the change, the most obvious part that's been discussed over and over again is writing pull requests and writing commit messages that we have fought a lot over with engineers that hey, you need to change this, your description is not good enough. I think that work is already done. We don't need to fight over this anymore. It's really good and it's going to be automated ways. Alright, now the issue problems is in the near second and third is that everything that was done in first two, and this is on top of that, is that I'm working with technologies that require typing these into SQL queries and figuring out optimization for APIs. And moreover, making technology choices for my team. So my normal workflow would look something like this. I'll read some books, do some searching, look at some technical blogs, let's just say Netflix about certain technology, read some documentation, accumulate this knowledge, go to open source community, figure out what's trending there, how they're trying to solve this problem, read some more technical blogs, and combine all this into an optimization or technology choice, right? So this is a normal workflow any team lead would be following before LLMs would around. All right, let us have a look at that. With an example, so we have this complex query here. It's pretty long and it was very hard with just in a single slide as well. It's taking in 3 different tables, trying to do a join on 3 of them. And one of this join interestingly involves working on a JSON to extract an ID and then writing some queries on it where we're trying to design a like index, right? So we're trying to use a like syntax and trying to use some expensive queries. So this query is timed out at 15 seconds. If I'm not using LLM, I would be using my previous flow where I would type these, start to figure out where to start, and I don't have an idea where to start looking at this huge query. And this doesn't end here. You can scroll this down and just go on, right? Let's see how Gemini does on this. So once you start, it lists out for us very basic things. If the query is standing out, have you considered indexing? It gives you the right columns you can start with. Other than that, it points out that you are using pretty bad approach on writing the where clause. You're using wildcard syntax that can hurt your performance. And moving down, something really stands out is hey, you're using JSON extract. You might want to consider if the size of the JSON that you're saving is huge. So as compared to my 2-3 day work is done with a simple query now. It does that in pros and cons that we'll get later, but it really gives me the key pointers to attack this problem. That hey, let's start from where we end and see where we get. Technology comparisons, on the other hand, let's just say you want to create an e-commerce website using Python. You can say sale or hostel or right upstairs. But there are few choices such as tech, gen, e-commerce that are not out there. So this highlights one of the weaknesses of the LLMs as well, where something that's been talked about for the past 10 years obviously has some more confidence in the LLM's evaluation to stand out, and the new technology will never get to this stage. So this doesn't really work out in trying to make a great knowledge to us. So here we are, it's in present. What we're trying to achieve here is, as a technical team, I'm trying to do MVPs. I'm trying to get those products out in a week, in 3 days, and even trying to write a code that's meant to be edited once in a year. Let's just say a CI/CD pipeline, right? So LLM has been a great help because that's something established out there that none of us really want to get into CI/CD because once written, you hardly touch that piece of code. And moreover, in terms of communication expert, for example, if you're using Jira for communicating, I don't necessarily need to learn JQL or electricity language or dive deep into documentation to figure out which issues have been stayed for past 3 days or past 3 months. It's not my job anymore. I just use natural language processing ability that LLM is really great at and get it to out dedicated use. And moreover, automation scripts such as writing a chatbot for daily needs. All of this is really straightforward in Gemini because these are small scripts that are really well done. Right. Some of these people might call out as, let's just say, pros and cons. I rather lay them down as opportunities to work on that we have. Pro really is that I have an augmented workflow. Con is that there is a loss of human connection. There is some shallowness and void that needs to be filled. And I believe with technology at the center, we need to adjust because in the long run, this resiliency has already started to adjust in some way. Thank you. Any questions?
Thank you so much, Yahya. Do we have any questions from the world?
It's in big.
So, as briefly, you mentioned about that, thanks, that space is issue of hallucination. I'll read a bit of a second, but this idea is going to be everything of that, right? You can really write code to some channel of Gemini or Claude or ChatGPT. All of them is generated before, right? But we need to show that it's keywords. Right? I was used to use sometimes it generating or with variable piece elements, right? And as well as very actually just using it like you and then it's what else this before. So how do you know Chinese data and how does that affect this? Jack, we've got Sepulver.
Anyway, yeah, that's an interesting. So there are two primary ways in which hallucinations are being addressed right now. The first one is obviously through stronger treatment elements. You might have noticed that GPT 3.5 hallucinates a lot, whereas GPT 4 or latest Gemini, Ultra, or the Claude does not do that. So the first thing is that people are actively working on training those stronger elements using even more data. And the second one is that they are using retrieval augmented image in order to generate more contextual suggestions and reduce hallucinations. These LLMs need an external knowledge source to work with. And once you that, you go the context of your code base and the libraries that you're using in, let's say, all the tags that you have open. And when you index that into a vector store, and then use that for generation to an LLM, that reduces the hallucination block. And actually, Copilot, if you have that system, does this, and practically, in my experience, it has reduced hallucination to other procedure.
Just to add on top of that, the purpose of using Gemini for all these tasks was to give you an idea of the scale a dedicated LLM would solve your problems. This is a very general public LLM Gemini problem that it solves a very diverse set of problems. So if you use something like Google Copilot, it's probably going to perform real well. if you any other class.
You remember state. He's got a in this point, but they did not in his time.
So I have a person, essentially I of you around that this are how we here. They all have the information on this the line of the civic setups. So if you're working on any platform, and it's whatever platform here, and what would you recommend? So the terms of all maintaining workflows, so you might have this in the campus or the ways that are thinking about it or vacancy or the strategy that they did not do that. Even if you pointed out users, they find a way to significantly. So what is a positive?
Yeah, so for that scenario, actually, again, we keep it over generation. And the way that you get it right now is to Django. What you can basically do is like just provide documentation to Django to that particular. It will first read all the documentation, index that to the and then perform events to it. So now it has the key knowledge of the
Just so there are two approaches to it. One is that you rush forward and solve this problem for the minute. The other one is just lay back for a while and Django will come up with a RAG and does this problem. So I'd rather do the second one because we've seen how fast the things in the progress from 3.5 to 4. So there were a lot of products, there were a lot of buzz that they didn't get the right order for them. They're not disciplinary because the people with the action they are coming forward with those solutions. So yeah, that's another way of doing things. Yeah, sir.
No, I heard shit. So with all of these advanced rates, SFC is the one we have. So like, is there any decision on the debate? Is there any around this how the self home develops faster because you will see that our independent aggregates very yes the our problem setting like you can see with that value very useful and very institutional out there. So is there any research to go know what it is or like part of this?
So you're ready to question evaluation of reference?
Yeah, me and here to I said this is the be as a
Definitely. So let's talk about science. So students are actually using these elements like solving programming challenges in their assignments. And there are actually multiple policies that are being emerged right now that will do this. One way is to tell students to do the same assignment way that it out there and just compare how it's the output. The second one is that give them a problem that's unique in the sense that they can't solve it directly through an LLM. They just need to first organize that problem, identify the higher instances, and then they publish right code. So there are actually multiple, this is actively evolving space right now. And for students particularly, there are different policies that are being adopted. And if I go to the second part of the question of developers. So at the end, if the developers are solving a particular problem, whether it's by using LLMs or whether it's by using the code, if that's separate enough, I think while building a product to that effect. But if you are more concerned about training with developers, then you can come up with some coding challenges that actually highlight the product system design instead of just generating code about it. So there are actually different methodologies that can be opportunities for.
Yeah, it's very cultural that we at Arbisoft are recently facing the targets, online tests, how to fill. I believe we don't have answers yet. So we are at a stage in my point of trial or something as he has mentioned that let's go into those problems that don't have one fixed answer. Let's see how students are doing there, because that's the university challenge. Another thing that we get challenged is we know the limitations of LLM and we design silly questions beyond that. Because LLM will eventually, because they used to struggle a lot with even 2+2 0 in early days, right? And we know if the problem is complex enough that the students cannot solve from LLM, especially the reasoning part, they're going to struggle. And the third part, I believe, since I'm already doing this. I don't expect anyone of you who is coming to me or doing this professional test. It's not going to be the LLM. It's designing my problems with it. So I expect you to use LLM, but I still have some sort of challenge in there that will want you to go beyond the basic user LLM. So I think the right way to attack this is start assuming the LLM will be used and just decide to go beyond and design accordingly with that.
These are the last question. One.
So, might have heard that media CEO has recently said that kids don't need to learn coding anymore. What do you say about that?
I mean, like, English is becoming the new programming language, and you are just doing generate code by using LLM. I think that's clear. But I think slowly the challenges are becoming more higher. This time about Python instead of using a low level language where just to Python. What's the next level of strategy? That's obviously using LLMs in your workflows. I don't say that you don't need to learn the code, but just by augmenting LLMs in our workflows, I think you can just do really well.
Thank you, Azeemi, Yahya.